whenever there are problems, we need tools to solve it or things to solve it. Here the problem statement is one car fell into the river when it was driving through the riverside. So quite obviously the crane, people are happy that they have an opportunity to lift something. They came and started taking it out. Now, this was a problem statement which we have created, that is the car fell into the water and we found an appropriate tool to use it. Okay, so we have used the tool and got the solutions or got the problem solved. Now, you look at this. Did the tool fail or something else fail? I'll ask you to type in and see what did fail here. What's the problem with the tool or something else? The car which is fell in a river, and for people who lift this, it's their normal job and there is absolutely nothing they need to really worry about. They come and take this kind of task very easily. Now, what did fail here? Do you like to give me a response? Okay, miscalculation. Good. Dr. P. Arun has given a comment on a chat. I would encourage all of you to chat. All of you to improper tool usage. Yes. Length of the rope or tow. Okay. Position of the crane. Load balancing. Good. Dr. Naveen has given that. Very good. Improper mechanical advantage. Good, Krishnan. Very good. So there are there's a center of gravity is mentioned, improper forces are mentioned. Good. So you started looking at it as, is the tool fail me or something else fail me? Let us see. Now we have two problems to solve. One was a problem which we tried to solve first. That could not be done with available tools. So we went for a much bigger tool. So linear analysis is not working. We are going with a nonlinear analysis. We just looked at a nonlinear analysis, much more sophisticated things. We thought the tool will obviously give me better result. So the small car which was taken out, that was cakewalk. It could take very easily. Now we have another problem. And we are so good in creating problem and trying to solve it. Plastic is one good example. And we create a problem and try to solve it. Now we have created one problem and now this needs to be solved. So we have a much better tool and I'm sure that the tool should do its work. So be very clear. A tool is going to help as long as you know the basics. And never ever think that an advanced tool will help you so that you can get the things done. So as teachers, what we need to emphasize on is to make sure that we get our students get the basics so clear. So how do we make that basic clear? The clarity on the basics can be provided only when they experience it. They should experience that basics. Then we are doing our job well. That can be even in this pandemic, in these online classes, we should be able to do it so well because we have tools ready for you in virtual lab that most of the subjects you should be able to make use of it. Assume that in some area it is not available, then we can create it. So why we need to worry? We know what to do and we have the basic concept what has to be put together, then all of us together can even create it. So our request is go through the available virtual labs and make use of it extensively during this pandemic period. And if you find some gap, obviously there will be a lot of gap, we can create it together. With that, I will wind up my session. Thank you for a patient listening as well as very active participation in the chat. I'm so happy that many of you participated. I hope you will also make your students to participate in your online classes so that you really get them in so you feel that you are taking a normal class because you may not be seeing the face. Now, absolutely, I have no idea who are all on the other side, but still looking at the screen, I am smiling at it, thinking that all of you are there on the other side. That's the same condition for us when it comes to our online classes. So enjoy the class and make sure that our team is ready to explain you things. Make sure you are getting the best out of them and please use it in everyday classroom so that you you are really able to do the best job in your area as such. Thank you for the patient listening. I'll just wind up and hand it over to the VTU team.
Hello. Yeah. Thank you, sir. Yeah, Shrestha, you can go.
Yes, sir. Yeah. So thank you very much, Gangadharan sir, for the voting session and briefing about what exactly is this virtual lab platform. Yeah. So for the participants, if you have any queries till now, you can. Professor Gangadharan sir is available, so you can either write in the chat box or you can unmute your mic and ask. So if you have any queries till now, you can just type in the chat box or unmute your mic and ask. The session is open for questions.
Yeah, I have taken only some physics examples because I know that my other team members are ready with the other domains. So if domain-based question is this lab available, etc., you can hold on. They will explain you one by one because all of you together, because for the last 5 days we have been taking civil, mechanical, all that separately. And every time we had this difficulty that there will be at least 3-4 groups together who are going to attend the webinar.
Sir, this is Dr. Jagdish from Sir MVIT.
Okay, please go ahead.
Good morning, sir. Firstly, I would like to thank you for a scintillating talk. It's a wonderful presentation. And I represent Biotechnology Department. So you have shown that simple pendulum experiment, right? So you triggered that, right?
Yeah. Yeah.
So, how was that connected? Because, when we do some life science experiment, it's very difficult to, do these sorts of things. Yeah. The triggering system, was it that connected? How it was connected? I was thinking, sir.
Yeah. So I'll explain you, sir. Now, whenever we find something is difficult, we are more energized because if it is so easy, why we should do it? So for me, when I talk about an idea, if people are not laughing at it, I won't even take it up. Okay, so that's the approach. So if it is more difficult, let us do it. So now here what we did is, obviously, it involves communication, it involves computer science, it involves electronics, and the domain understanding. Because somebody should not come and do misuse with my system because it is kept open throughout, that is 24/7, and we don't even ask for a login. So I don't know who is using it now, rather than which domain they are coming from, which IP they are coming from, which physical location, we will be able to figure it out on the analytics, but otherwise I don't know. So any of these things, what you need to do is how we trigger or how we initiate that experiment has to be coming from the domain expert. I will give you a simple example. The experiment which I have shown, not the trigger, both the triggering one as well as the one on the cantilever. A beam is held and we need to pull it down and leave it. So it's called in electronics parallel or physics itself, we call it as a step input. So that after that input, it goes up and down for a few times. And once the input energy given is consumed, it comes to rest. So this, when I said this, people asked, how are you going to pull it down? I said, I will use a magnetic field. I just had an electromagnet, just pulled it and released the electromagnet and it went up and down. So like this, you will get an idea about, suppose you are going to mix two things or you're on a growing medium, you want to put something and you want that to be shown on a screen and what is the growth rate, how the shape changes, etc. All that can be visualized and put in place in technology. Because remember, our space shuttle is being controlled from Earth. So technologies are available. Only thing is that we have not started thinking about it in an education. And operations are done remotely. Now robotic surgeries are done. So it's all available. Now only thing is that we need to see how we can make it cost effective as far as possible open source so that others can also contribute. Things of that kind is the worry. So you will see some of the experiments done by, I think it is Amrita University, Amrita Vidyapitham. Some of the biotechnology labs are available. But they have not kept anything on remote trigger because it is very expensive. Even for us, we are bleeding when we have to keep the remote triggered lab because ministry said we may not be able to support you further because they gave the project for 2 years. After that, they said the project is not being continued. Hence, but we have been happy that it is continuing for us. For so far, there was no issue.
So that experiment was from your esteemed lab, is it?
Pardon, sir?
That experiment was from your esteemed lab, sir?
Yeah.
Whatever. Oh, that's great. That's great, sir. Interesting. Thank you very much, sir, for a scintillating talk. It was so inspiring for all of us.
Thank you.
Thank you.
Any other questions regarding how do I use it or something of that kind? Some basic things which comes to your mind, no? As a teacher, sir, syllabus cover madlike agtada. Those kind of things. I mean, I'm just waiting for one or two questions, then we will close it up.
Hello, sir.
Please go ahead.
Sir, myself, Dr. Gurnath from SLN College of Engineering.
Okay.
Sir, I want to be show to the student that how to show that single cantilever experiment to the student by using virtual lab.
So,
because we want to focus on microscope, traveling microscope on a tip, and you have to show the depression. How can I show to the student? Please explain.
So suppose if you want to show it as an actual microscope and show different bacteria or things of that kind, or if an indentation and type of indentation, we need to connect the microscope using a camera and the feed has to go in a web page. That is how it is. But instead, we suggest you to look at the simulation. The biotechnology as well as biomedical instrumentation, many experiments have been simulated. So for us, the beam, I have not shown you the beam experiment. Actually, there is also a beam experiment which is from our side. That is, I'll just show you quickly. Let me just see whether I can show you this experiment. I'm sorry, I think I have not presenting my screen. I'll just present the screen. So I'm looking at one experiment from, it's coming, free vibration of a cantilever beam. This is the actual experiment I have shown you as a remote triggered experiment. This is a simulation experiment. It is on flash, hence you need to allow flash to operate. On a mobile, it may not work because now flash is not being supported. Hopefully within some time, within few months, we should be able to convert all this into HTML and Java. So this is a simulation experiment. What you saw in the previous demonstration was an actual experiment where remotely I am pulling the beam down and leaving. So when you pull the beam down and leave, it moves like this because you have imparted some energy and you have given changes the position. The potential energy is that what you are imparting because you are lifting it, moving it down and leave. So at that point, at that time, t is equal to 0, no further energy input is given. That means the input given has to be sustained or unless and otherwise somebody is consuming it. So what happens is, whatever input you are given, you can see here, this was the displacement we got. Okay. As it comes here, this is